All right. It seems like most people are here. That's my phone. Um, if you haven't checked into on campus, you need to do that. And I'll just put it this way: if we continue to use the chat as it's not meant to be used, I'll take away the attendance points. All right. Um, so I'll just put that out there. All right. A couple things I want to do today. I want to go over a quick example. I got an email saying he didn't quite understand how to do like finding the rule for the sigma notation. Um, so we'll do an example of that, a little bit harder of an example, or a little bit different of an example, but one that I hope can get you to think about it a little bit more deeply. All right. After that, I want to go over arithmetic sequences and sums and partial sums and just rules of arithmetic sequences. Okay. After that, I'll give you a bit of homework, and you should honestly have quite a bit of time to work on it. And after that, I'll be on Teams. You can ask me specific questions. Hopefully, it's not chaotic. Uh, but yeah, that's where we're headed. Um, After this class, we'll go over geometric sequences, and then after that, I believe we actually start to do a little bit of probability work. So if you're really looking forward to that, that'll happen probably late next week, uh, and then we'll get to some pretty fun stuff that does legitimately apply both to everyday life and to future classes in calculus, both AB, BC, stats. It'll apply a lot to next year. Okay. And it's also just a cool concept that everything we're doing right now is applicable not only in real life but to future classes, like legitimately. Um, I feel like all the rest has been really building blocks. This is some fun stuff that you get to use next year. All right, so on your screen, I have an example from your book. It's like 9.2, I think the example is from 9.1. The example is from, and it's number 112. I don't know the exact page, but it is in your book. Okay, so if you want more examples of this, they're in there. I have answer keys, so if you ever do a problem just to like practice it, um, I have the answers here, so you are welcome to do those. But the directions for this to use sigma notation to write the sum of the following sequence. All right, and that sequence is 1/2, 2/4, 6/8, 24/16, 120 over 32, and 720 over 64. And these are purposefully not simplified. Okay, the book did that for a reason. And in order to do this, the first thing we need to do is actually find a rule for the nth term, because that's the first thing that goes in the sigma notation is some rule an. So in order to do that, we need a rule for the numerator, which I'll do in red, and a rule for the denominator, which I'll do in blue. All right. So let's take red for a second. So 1, 2, 6, 24, 120, and 720. So if you look at this for a couple of seconds, it might not seem obvious what the rule is, but we did go over this briefly. We need to be able to get from the terms in white to the terms in red. So we need a function of the things in white in order to get to red. So we need to be able to get from 1 to 1, 2 to 2, 3 to 6, 4 to 24, 5 to 120, and 6 to 720. And if you think about it long enough, you should be able to get that. For example, 4, and to get from 4 to 24, that's 4 times 3 times 2 times 1, right? To get to 3 to 6, that's 1 times 2 times 3. 5 to 120, that's 1 times 2 times 3 times 4 times 5. Okay, so this is following, this red part is following a factorial rule. So an for the top, for the numerator, it's just n factorial. Okay, and I get that this isn't something that you've done a whole lot of. It's something that you haven't seen a whole lot of. We didn't practice a whole lot of it. We did go over factorials, and this does show up in sequences. Okay, so that's the numerator. And we can test that, which we already kind of did. So I'm not going to spend a whole lot of time on that, but I'll pause there. Are there any questions over what we just did in red? Okay, then we need to find a rule for the bottom, for the denominator. So we have to go from 1 to 2 to 6 to 20 to sorry 2 to 4 to 8 to 16 to 32 and 64. Viewer count is a little low. Your viewer count's a little low. All right. So we need to go from first from 1 to 2, from 2 to 4, from 3 to 8, 4 to 16, 5 to 32, and 6 to 64. Okay. And again, this takes a little bit of practice, and you'll get this as you get more experience doing this. But immediately I noticed that all the blue numbers are just doubling, which is a good indication that it's some power of 2, right? So our rule will be 2 to some power, right? And if we test that, a1 would be 2 to the first, which works. That's just 2. a2 would be 2 to the second. That works. That's 4. a3 would be 2 to the third, which is 8, and so on. So it works. It works for every term. Okay, so now we have two rules, one in blue and one in red. So our overall rule for this entire thing is an is equal to n factorial, that's the top rule, divided by 2 to the n, which is the denominator rule. Okay, so again, I'm going to pause just for a second. Are there questions about how we got there? All right, so this is a good rule for the nth term, but that's not our question. Our question is to use sigma notation to write the sum of the given terms. All right, so in order to do that, first we need a count, right? So we have 6 terms. All right, so our sigma notation will start at n is equal to 1 and go up to 6 of this rule. And then this is our answer. Okay, so this is a little bit different than the IXL questions. I think the IXL questions are actually slightly easier in a couple of ways, but it's the same type. Okay. So before we go on, are there any other questions about these types of problems or the IXLs that you did for today? Okay, so what we're doing today then has to do with arithmetic sequences. And if you remember, I think I mentioned this in the last lecture. An arithmetic sequence is a sequence that just adds the same number over and over again. So the formal definition, a sequence whose sequential terms, so each term, have a common difference is called arithmetic. Okay, so if we have these terms A1, A2, A3, A4, all the way up to AN, and then so forth. This is arithmetic if, when you take the difference between each sequential term, you get the same number. Okay, and this number is called the common difference. Which is very, very important for arithmetic sequences. Okay, so again, arithmetic is you're just adding some number over and over again. That number that you're adding is called the common difference. That's really all that definition says. And down at the bottom of your screen, I have two sequences. Okay, and we want to determine just if they're arithmetic or not. All right, and in order to do that, all we have to do is subtract each two terms. All right, so I'll do -3 minus 2 is -5, right? -5 minus -3, sorry, -3 minus 2, that's -5. -5 minus a -3, I think I wrote this down wrong. Yeah. That is not how it should be written. That's better. Okay. And that's not right either. Okay, give me 1 second. I wrote this down wrong. Okay, so this is what was supposed to be written down. All right, so 2, -3, -8, -13. We want to just determine if that's an arithmetic sequence. Okay, in order to do that, we just take the difference of each two terms. All right, so -3 minus 2, that's -5. Negative 8 minus a negative 3, that's also negative 5. Negative 13 minus a negative 8, that's also negative 5. Okay, so this, because this is constant, we know that it's an arithmetic sequence where this negative 5 is called the common difference. So determining if a sequence is arithmetic or not is really easy. You're just taking the difference between each two terms and you're seeing if it's constant. If it is, then you have an arithmetic sequence. For the second sequence, if we take the difference between each two terms, so 4 minus 1, that's 3. 9 minus 4, that's 5. And already we can stop because these two things are not the same. So because of that, it is by definition not an arithmetic sequence. Questions about what I have up on the screen? And when we're dealing with arithmetic sequences, there's a really easy way to find the rule for the nth term. All right, so for any arithmetic sequence, the nth term is defined by the first term plus the common difference times the number of the term minus 1. Okay, and we'll do an example of that. Okay, but this always holds true for an arithmetic sequence. For example, we want to find a formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2. Okay, so if we just write those terms out, our first term is 2, and we have a common difference of 3. So we're just adding 3 over and over again. So our sequence will look like this. In order to get the rule for that, all we have to do is take the first term, which is 2, plus n minus 1 times our common difference, which in this case is 3. And then we can simplify that. So our rule for the nth term then is 3n minus 1. Are there questions about that so far? The most important thing that you can get from this screen, I guess, is that equation. So then we can get to a little bit more challenging questions. All right, the fourth term of an arithmetic sequence is 20, and the 13th term is 65. We want to find the nth term, then find the 11th term. Okay, so let's first just define what we have. Okay, so we have the fourth term, which is equal to 20, and we have the 13th term, which is equal to 65. the most important thing that we can get from this is the common difference, okay? So we need to determine how many terms are in between 4 and 13, which is just 9, right? So if we divide the difference between 65 and 20 by 9, we'll get our common difference, right? Because we're adding something over and over again 9 times. So our common difference then is just 5. Are there any questions about how I got that? Okay, then, so we got like a common difference, but we still need to find the nth term and the 11th term. So in order to find the nth term, we have to find the first term. Okay, so if a4, rather a1, would equal a4 minus 5 times 4, right? Because the fourth term is the first term plus 5 4 times. So then we have 20 minus 20, so that's just equal to 0. All right, and our rule then we have all we need for our rule. All right, so an is equal to 0 plus 5 times n minus 1. From that, we can find the 11th term, and then we're done. So I get that this thinking is a little bit different. You're kind of set in a pattern of thinking where everything is very direct, and you don't have to be very agile with the way you're thinking. In this case, you kind of do. Okay, there's not one like set way to do it. There are a number of different ways you could have finished this problem. Okay, but so long as we know this equation and we know what an arithmetic sequence is, we should be able to get the right answer no matter what. Okay, so again, I'm going to pause there real quick. Are there any questions over what's on your screen? So we haven't just dealt with sequences here and rules of sequences. We've also dealt a little bit with sums. in sigma notation. All right. So in order to find the sum of a finite arithmetic sequence, we could sum a bunch of things together, but that takes a lot of time. And there is a function in your calculator which does it for you, but there's also a lot easier way to do it. Okay, so in order to find the sum of an arithmetic sequence, we have an equation for that. And there is a proof to it. You don't really need to know it. If you want to, I can go over that later. But right now, we just want this equation. Okay, and really, it just boils down to summing the average of all the values together some number of times. Okay, so you average the first term and last term, and then multiply that by however many terms there are, and you get the sum. Okay, so this is another equation which we just need to know. And what this says is that the sum of the first n terms of an arithmetic sequence is the number of terms we're summing divided by 2 times the first term plus the last term. So for example, and this again is directly out of your book, find the 150th partial sum of the following sequence. And we're given the sequence 5, 16, 27, 38, 49. And I'm just going to tell you, it is arithmetic. All right, so the first thing really we need to do is to find, so we need each of these values, right? So we need n, we need a1, and we need an. So we need the last term that we're summing. Okay, we have n, that's 150. We have a1, that's 5, but we don't have an. So we actually need to find a rule for an. And rather, we don't have an, we don't have a150. We don't have the last term in our sequence. Okay, but in order to do that, we need to find a rule for the nth term. Now we know that this is arithmetic, so the common difference then is just 9. So in order to find a rule for the nth term, we just plug it into our formula again. So our first term is just 5, and then our common difference is 9. And then from that, we can find the 150th term. So then we have our 150th term if we just simplify that. Okay, so then that is really all we need in order to find the sum of all those numbers. So again, then we just plug it in. And evaluate. And when we evaluate this, we should get 101,325. Should D equal 11? Yes. Yes, it should. Okay. Yeah, I do a little bit of this different then. All right. Back to the beginning. All right. Okay, so if we redo that, we should get that the 150th term is 1,644. And then we can plug it into our equation. So the sum of the first 150 terms, the 150th partial sum, is equal to 150 divided by 2 times 5 plus 1644. She should get 123,675. Okay, I realize I screwed up there. Does anyone have any questions over this example? All right, and then this brings us to our homework. And your homework is W11 on IXL. Okay, so I want to go over one example of what this actually looks like. And then I want to go over like a better example, just because it's a little bit more real life. All right, so this is saying that we want to find the sum of this. And yes, you could do this by hand. You could do 4 times 1 minus 3 plus 4 times 2 minus 3 all the way up until 16. Okay, but we're only going to be dealing with arithmetic sequences in here. Okay, so we can actually plug it into our equation. And get an answer. Okay, so in this case, we're finding the 16th partial sum, where the first term is just 1. Okay, and I know that by plugging that into the rule, and then we can find the 16th term by doing the same thing. Which is 61 So you should get 496. Okay, and that's just the answer. Okay. So that lower limit, that's your first term. Your upper limit, that's your last term. And then you just plug all of that into your equation and you get an answer. Okay, now the number n will always equal the difference of the upper limit and the lower limit. Including that, so this should just be equal to 16. So ignore what I just said there. Okay, but if you have something that starts at like 4, for example, you have the 4th term, the 5th term, the 16th term, the 6th term, the 7th term, all the way up until the 16th. So if you just count those, that would be the number of terms that you have. Okay. So that's your homework. Are there any questions about that? I realize I kind of fumbled through that last bit. Okay. And then I want to do one example that's a little bit more realistic. The starting salary for an accountant is $43,800 with a guaranteed increase of $19.50 a year. Determine the salary during the 5th year, find the amount after n years, and then determine the total compensation through 5 full years of employment. Okay, so determine the salary for the 5th year. And actually, it's probably easier to do the middle question first. So then we can use that for the first and third questions. All right, so let's start here. Okay, and from this equation, or from this question, you're always going to get $19.50 a year. That's just guaranteed. Okay, so we're adding $19.50 over and over again, so it's just an arithmetic sequence. And our first term is $43,800. So our rule for this will be $43,800 plus n minus 1 times our difference. And then we can simplify that a little bit. Okay, so our rule is 41,850 plus 1950n. So the salary during the 5th year would just be A5, which would be equal to 41,850 plus 1950 times 5. So in the 5th year, you'd be earning $51,600. And then this last bit, determine the total compensation through 5 full years of employment. That's a sum, okay? So we want the 5th partial sum of an. right? So this is just equal to, we have 5 years, divide that by 2, times the first term, plus the last term. And if we evaluate that, it's $238,500. Okay, so that's the total number of money that you would make over 5 years, given that common difference and nothing else changing, right? So this seems really simple, um, but it's really cool because just given this like 30-minute lesson, right, you could plan a whole lot financially. And people use this day to day. And if you're really, really smart, you can make like a financial plan for several years, given what you know and what you're guaranteed. Okay, so even though this stuff may seem like really abstract, you're using this every day, or people are using this every day in order to plan very detailed things for upcoming years. Okay, um, so that's all I have for you right now. Okay, your homework, like I said, is W11. Um, I will leave this open for a minute or so. So if you have any like specific questions or general questions, I can answer them here. After that, I'll go on to Teams. I'll start a meeting, and I can ask. I can help you with more specific questions. Okay. All right. So I'm going to close this, and then I'll be on Teams here in a minute. I'll open up a meeting. If you have any questions there, you can just ask. All right.